Let's look at some other aspects of sentiment analysis, like linguistic negation and the use of lexicons. One important issue that comes up in sentiment classification is linguistic negation. So the sentence, "I really like this movie," is very different than the sentence, "I really don't like this movie." So here, negation changes the meaning of like to a negative. And it can also change the meaning of a negative to somewhat more positive. A negative sentence like "dismiss this film" can be softened by "don't." Negative to positive, not quite as strong as positive to negative, but a very important word to deal with. A simple baseline method dating back to really the beginning of sentiment classification is to just add the string NOT underbar to every word between a negation, a linguistic negation, a not or a never or a no or a don't, and the following punctuation. So we might take a string like "didn't like this movie, comma, but I," and because "didn't" has a negation in it, we add not underbar to like, this, and movie, and stop when we get to the comma. And what we've basically done is we've doubled our vocabulary size. We've added a not like and a not this and a not movie token to our vocabulary. And now the not like token is going to be a great cue for a negative movie review. Sometimes we don't have enough label training data, or the training data and the test data are drawn from different distributions. And in such cases, it can be useful to make use of a pre-built word list called a lexicon. And there's lots of publicly available lexicons that are used for sentiment. So just to give a couple of examples, the MPQA Subjectivity Cues lexicon labels about 7,000 words for whether they're positive or negative. So admirable, beautiful, and confident are positive words, and awful, bad, catastrophe are negative words. Or the General Inquirer, another early lexicon dating from the 60s, has a list of positive and negative words, and lots of other lists of words, active versus passive, or pleasure or pain, or strong, weak words. The way we use lexicons in sentiment classification is to add a new feature that gets a count whenever a word from the lexicon occurs. So you might think of this feature as this word occurs in the positive lexicon. So when we see a positive word like good or great or beautiful, any one of them, we add one to that count. So before we were adding one to good and one to the count for great and one to the count for beautiful. With lexicons, we simply add one for any of these occurring. So that kind of sums over all the possible positive words or negative words for the negative word feature. And so now we've only got two features, a positive word feature, a negative word feature, where before we had lots and lots of lexical features. Nonetheless, this can be helpful when the training data is sparse, we don't have really good counts to make use of, or perhaps the training data is not representative of the test set, so we can't rely on the same words appearing in training and test. So in those kind of cases, these dense lexicon features can help. Of course, naive Bayes is useful for other kinds of tasks with text than sentiment. So spam filtering is one famous example. So some features from a naive Bayes spam classifier, if the text mentions millions of dollars, or if the from starts with numbers, or if the subject line is in all caps, or if you see the phrase 100% guaranteed, or some claim that you can be removed from the list. These are all features that suggest that you're looking at spam, and we can build a naive Bayes classifier with features like this. Naive Bayes can also be used for language identification. So that's the task of determining what language a piece of text is written in, and it's a very important pre-processing step. And it turns out that features based on character n-grams do very well for this task. So certain kinds of character n-grams are very distinctive for certain languages. It is important to train on different varieties of each language. So for example, for English, you want to make sure you train on American English varieties like African American English, or English varieties around the world like Indian English. In summary, naive Bayes really isn't that naive. It's very fast. It has low storage requirements. It works well with very small amounts of training data, which is not true for many of the more powerful algorithms we'll see. It tends to be robust to irrelevant features. It's good in domains with many equally important features, which is not true for some other machine learning algorithms like decision trees. And in fact, naive Bayes is optimal in the rare case in the world where the independence assumptions actually hold. So it's a good, dependable baseline for text classification. However, we'll see other classifiers, logistic regression, neural networks of various kinds, that give better accuracy when there's enough training data. We've now seen further aspects of sentiment classification and other tasks that naive Bayes can be applied to, like spam detection or language identification.